Hi everyone, in this video I want to give you an introduction to tests for comparisons. Introduction to tests for comparisons. Okay, in our previous concepts we talked about hypothesis testing, but what we talked about were only testing on one population or one thing, one subject. So before hypothesis testing on a single population. Okay, of course, only just one thing. Okay, but from now, what we're going to do, we want to do a testing on comparisons. So from now, we're interested in, say, compare two populations. Compare two populations. Okay. Let's say we want to ask the question whether contact lenses are better than glasses, right? So whether they're better, and or maybe you have Michael's reading class and Michelle's reading class, and you want to ask whose class is better. So we're doing comparisons. And when we do comparisons, there are two types of tests that we can use. So two types of comparison tests. Okay, so the first one is what we call independent test. Second one is related test. Okay, so there are two types. Let's first talk about independent tests. Okay, so let me give you an example, and just using this contact lenses example. So the example, the question we want to ask is contact lenses effects different than glasses effect, right? So whether wearing glasses, it's different than wearing contact lenses. So that's the question we want to ask, whether they're different. So the null hypothesis we want to have here is comparing these two populations. Okay, so instead of comparing a population to a number, we're doing it. We're comparing two populations. The null hypothesis would be mu contact lenses equals to mu glasses, right? So they're the same, and the alternative is they're different. Mu contact lenses not equals to mu glasses. Okay, so how you would do an independent test to answer this question? So how we do this? So use independent test. Okay, so first you will pick a sample group, right? Pick a sample group, and then we're going to assign them to contact lenses. So assign to contact lenses. Okay, and then we're going to pick another group. Pick another group or another sample, right? The word another is important here. So it's not the same set of people, or it's not the same sample. Pick another sample group. In this case, we're going to assign them glasses. Okay, so one group of people, contact lenses, another group, glasses. and we're going to see the difference. Okay, and the next thing is, and we're gonna test the effect for both groups. Okay, we're gonna test the effect for both groups. In this case, I want to point out the concept of independent here. So the two groups are independent, right? The two group of people are independent because they're just not the same group of people. You know, group 1 of people is for contact lenses, group 2 is for glasses. They're totally independent to each other, and that's why we get the name independent test. Okay, so that's why we have independent test in this case. Okay. Now let's talk about some problems or bad things about independent test, or why it's not very good, or what's missing from this independent test. Okay, so I'll just say drawbacks. Independent test. Okay, so what are the drawbacks? The first thing I want to point out right away is we're not guaranteed, we cannot guarantee the differences in results are from the factors we consider. Okay, so the factor we consider here is contact lenses compared to glasses. So that's the factors. And maybe the group of people that are using contact lenses, they're just really self-fitting to the contact lenses. You know, maybe it's their eyes are more adapted to contact lenses than glasses, and it's their self-advantage using one type of the product. Maybe someone's their eyes are just really adapted to glasses compared to other group, right? So there's just so much self-factors involved that we're not really testing, or we cannot really contribute the differences we see in results to the factors we consider, right? In this case, the factor is glasses compared to contact lenses, okay? And because of this, we are less likely to make the conclusion that there's a difference in the factors we consider, okay? So because of this, we are less likely to conclude differences between factors, right? And when we call factors, we're actually talking about two populations we're comparing the two, or let me just put down populations. Okay, so we're less likely to conclude differences because it's just not, we're not guaranteed the differences are coming from the factors we consider. And based on this, another way to say this is we're less likely to reject our null hypothesis. Okay, so we're just less likely to reject our null hypothesis. Okay, then the alternative is the different one. So we're less likely to reject this. So we're likely to say this one might be true. Okay, so the problem for this, it also connects to less likely to reject no, even when the no is true. I mean, when the no is false. When no is false, right? So even though the no is false, we're less likely to reject the null hypothesis. And what it means is the power is smaller. Power is smaller. Okay, remember power? We talked about in our last video, the power, the definition is the probability that you reject the no when the no is false, right? So in this case, we're less likely to reject the no than the power is smaller. Okay, very good. Now let's talk about related tests. Okay, and type 2 is our related test. Related test. So in related test, what we're going to do, so if we go back to the same example, we use only one sample group. Okay, we're going to use sample group, and then we're gonna first give them contact lenses for them to use, get the effects, and then we're gonna give them glasses and give them glasses, and then we compare the results, right? And then we're gonna compare the results. Okay, so now the sample is dependent to each other because it's just same group of sample. So now sample is dependent to each other because they're just the same group. Okay, so sample is dependent, and therefore in this case it's what we call related test. Okay, so here we have related test. Okay, because the samples are related to each other. So in related tests, because just same group of people, and then any difference we see will contribute, or any difference we see will contribute those differences to the factors we consider. So in related tests, we're more likely to reject the null hypothesis. Related test, more likely to reject your null hypothesis. Okay. So in related tests, we're more likely to reject null hypothesis, and therefore related tests are more powerful than independent tests. Okay. So related tests are more powerful, right? Because we're more likely to reject null hypothesis. Okay, it looks very good, but there are also some problems with related tests. Okay. Drawbacks of related tests. Okay, for the drawbacks, the main problem is that related tests form bias, right? Inform bias. So bias is something that's on average you get it wrong. Okay, we'll get more detail into bias, but bias is only happens in related tests, and there are two types. That's what we call the first one. The first type of bias is order effects bias. Next one is carry over effect bias. We'll talk about each one of them in the next video. But one thing I want to mention before we end this video is bias problem only apply to related tests. They do not apply to independent tests. Okay, this video gives you an introduction to tests for comparison, and thank you for watching. I will see you in the next video.